Okay, to fast forward, we can see that these amounts come out to about 1.445 moles of potassium, 0.728 moles of carbon, and 2.172 moles of oxygen. Although this allows us to condense the relative amounts of each atom in the molecule, this reduction doesn't amount to whole numbers or integers, so therefore we need to go one step further, and the next step is to divide each of the molar quantities of the different atoms by the amount that has the least amount of moles. In this case it's carbon, so we're going to divide each by 0.728. I'll begin with potassium. One point four four five moles of potassium divided by 0.728, and this equals 1.985 moles of potassium. As you can see, this is approximately 2. Next, let's evaluate carbon. This is very much straightforward. And this would be a good time to fast forward. And again, we see we have a value that's very nearly rounded up to the next integer. So we can take confidence in rounding up these values because it's essentially a very insignificant difference between 2.98 and 3. So in this case, this brings us to our final step. We can now express the relative amounts of potassium, carbon, and oxygen using these values. So for potassium, I'm going to use 2, carbon 1, and oxygen 3. And since there's only one carbon, I don't really need a subscript. So we have integers for each of the atoms. This is an ionic compound, and the name is potassium carbonate. And to look at how this is produced, essentially you have a group 1 cation, which is a metal, potassium. Because it's in group 1, all group 1 elements have a +1 charge. You have to just understand why the carbonate group has a -2 charge due to the covalent bonds between carbon and the oxygens. This is a polyatomic cation, or anion rather, and you would need essentially 2 potassiums to have an equal charge with the carbonate ion. So this is another reason, as I was talking about earlier. Yes, you can cross the charges and in some cases you'll get relative amounts. But this requires that you can recognize when you have a polyatomic group and where there's a dissociation between the two units. But it's probably a better practice to balance the equation using a coefficient. Because now you can see you have two potassiums here, one carbon, 3 oxygens, 3 oxygens.